Hey guys, welcome to the Wednesday video of the St. Edward Algebra Enrichment Program. Yesterday's meeting was awesome. We got a lot of really good ideas looking at the roots and the vertex of these different parabolas that we have. And we started looking really into the real world situations where they can really be seen. A lot of guys started talking about whether it was a projectile, so throwing something, or just building things, or engineering, or just different places in the world where you really do see parabolas. And I thought it was really cool to see. So if you weren't able to watch the video from yesterday to get a lot of the guys' ideas, I would definitely recommend going through and looking at that before you kind of continue this video, because this video kind of goes off that a little bit. So I did say that in today's video, I will be going through and kind of giving a little brief explanation again of the roots and the vertex of these different parabolas. And then I'm going to start off by looking at kind of the beginning of what your project is going to be, that you can kind of get started. We'll talk a lot more about it tomorrow, so you can kind of go through and get that done, and then get it to me by Friday or this weekend, whatever is easiest for you. All right, but so looking at first, so what I did is I looked at just different parabolas that we have, and looking specifically at the roots. One of the biggest thing we said with the roots is that the roots are where the line or the parabola crosses that x-axis. So it's the points that are kind of like on the ground. So if you're thinking about it, anything that kind of travels in a parabolic motion, a lot of things that deal with gravity and things like that as well, or just any design of anything that we have that's in the shape of a parabola, has two ground points. And those ground points are what we call the roots, or the zeros of the function. And then the vertex is the point that's either the maximum or the minimum. So if you throw something up in the air, how high did it go and what point did it reach? Or someone said if something was kind of swinging, what's kind of the point on the very bottom of that swing? That would be kind of a good kind of way to think a little bit about the minimum of something as well. Okay, but one of the applications that I use for it specifically is I looked at a couple years ago, Aaron Rodgers. If you watch the NFL at all, Aaron Rodgers threw a football, a Hail Mary pass, and he threw it 68 yards. And they caught it in the end zone, I believe either to win the game or to send it into overtime. So one of the things that I looked at is, what trajectory did that football travel? And well, I found a picture of it online, and I added it to this Desmos graph, the one that we've been using. So you can kind of go through and add your own too for it. So what I want you to do is kind of take it, put it on there, and then try modeling it in some type of way with your quadratic equations and with the sliders and things like that. So he threw it at this point right here, and the ball went up in the air 78 feet and traveled 68 yards before the person caught it in the end zone. So they caught it. I made it that point, that 0, 0, and then my other route is at this point 68, 0, because the ball traveled 68 yards. So that's how far it should go that way. And then the height of it is halfway between 0 and 68, which is at 34. Well, that 34, 78, because I know it went 78 feet, I use that specifically, or that point, to kind of go through and help me with that. So you can actually go through and you can find whether it's something that's being thrown. I know someone yesterday was talking about an airplane flying or anything like that that's kind of moving in that type of sense. And you can really add that or kind of put it into this graph and kind of model it. So what I did was I played with the sliders a little bit and tried figuring it out. As I was moving it around, remember we were talking about how the A value, when it's negative, it flips it upside down. The B value kind of moves it right and left and up and down, and the C value, more specifically, just moves it up and down. So kind of playing with those, I got some A, B, and C values that gave me this specific parabola. It kind of might be hard to see on this video, but I'll send this to you guys so you can see this well and kind of use it as a good kind of starting point for you if you're kind of going through and doing anything. And I got my A value to be negative 0.0674, so you can type in numbers to get it a little bit closer. And my B value, I got 4.58, and my C value is 0. Because I didn't have to move it up or down from this y-intercept at all, because I kept my y-intercept at 0. So if you want to do that, it kind of makes it a little bit easier for you. And so then I got this parabola that kind of looks like what he traveled. So now I can find a lot of different things, like where's the ball at a certain time, where's the ball at a certain yard line, how they can kind of figure out where it's going to land and things like that. And it's really useful in that type of sense. So what I want you to do is I want you to think of something, that we talked a little bit about yesterday, and whether you can find a picture of it online, or if you actually want to take something outside and throw it, or you can find something outside that is in the shape of a parabola and take a picture of it and try measuring it so you know some of the measurements that you can put on the graph. So notice, I used the actual graph, and you can make your picture bigger or smaller by grabbing onto the corners and getting it so that it fits perfect on this graph, and then you can go through and find your quadratic from it. And so just kind of finding these different equations, and then once you have the equation, you can do a whole lot more with it, like finding the roots, finding the vertex, and then once you get into things like calculus in a few years, we do a lot more with it, like finding the rate or the velocity or acceleration that the ball is traveling at a specific time. And then you can kind of even get into like parametric functions. So there's a lot of different applications that you can do once we find this graph. But the biggest thing is being able to find the graph. Okay, so kind of find something, put it on here. I'll talk a little bit more about it tomorrow. I'll send this to you guys as well in this email that I just sent you that you clicked on to get here, so you can kind of use it as a reference as you go through and create your own. And once you kind of get it, if you do it a little bit today or tomorrow, you can send it to me and I can kind of show some of the guys. I know a couple of guys sent me some things yesterday after our meeting, which was awesome, that I'm going to be showing tomorrow as well. So if you got something that you've done, send it over to me and then I can kind of share it with the other guys to kind of help them out too. All right, but other than that, I'll see you guys tomorrow on our next meeting. And if you have any questions or need anything, please let me know. And always go Eagles.